Hello dears, this is the second part of the topic change of variables in multiple integrals. In the last lecture we discussed how to change the variables in double integrals. Now we can do a problem. Evaluate double integral over r sin x plus 2y into cos x minus 2y dA over the region r shown in figure. So we are given this region r here, which is bounded by these lines S1, S2 and S3. So here the integrand is sin x plus 2y into cos x minus 2y. So the integration of this integrand is somewhat difficult. So we can change the variables x and y into other variables. Since the integrand is sin x plus 2y and cos x minus 2y, we can change the variables as u equal to x plus 2y and v equal to x minus 2y. Okay. Now, by changing the variables, we will get this integral is nothing but double integral over r sin x plus 2y into cos x minus 2y dA can be written as double integral over S, where S is the corresponding region to R in the UV plane. Okay. Uh, Double integral over S sin U into cos V into dou xy divided by dou x comma y divided by dou uv dA dash. Okay, so for that we need to find dou xy divided by dou uv, that is the Jacobian determinant, and we need to find the region S in uv plane, which is corresponding to the plane R in xy plane, right? So first of all we can find that way S. Okay, so consider S1. Here R is the region in xy plane bounded by these three lines S1, S2 and S3. Okay, so corresponding to S1 we have S1 is on S1 we have y equals 0. On this line S1 we have y equal to 0 and x varies from 2 pi to 0, right? X value, the orientation is like this, so x varies from 2 pi to 0. Okay, and that is y equals 0. Therefore u equal to, that is 1s u equal to x plus 2y. Since y equals 0 we have u equal to x and v equal to x minus 2y. That implies v equal to x. So from this, that is eliminating x and y from this, we get u equal to v. That means this line S1 is the image of S1 in UV plane is the line v equal to u or u equal to v. Okay, that means it will be like this. V equal to u means it's like this line. Okay, if this is u axis and this is v axis. Okay, now we have here uh, on S1 x is varies from 2 pi to 0. So as we move from 2 pi 0 to 0 0, we have x varies from 2 pi to 0. Okay, so when x is equal to 2 pi or at the point 2 pi 0, we have x is equal to 2 pi. In that case we have u equal to x, and that is 2 pi, and v equal to 2 pi. Okay, that means and also when x is equal to 0, when x is equal to 0 we have u equal to 0 and v equal to 0. So this point, in this point, here this point is 2 pi 2 pi, and here the point is 0 0. That means as we move from 2 pi 0 to 0 0, we have already know that here is y is equal to 0. Okay, so as we move from this is the corresponding point 2 pi 0. Okay, and this is the point 0 0. In that case, on at this point we have x equal to 2 pi. So as we move from 2 pi 0 to 0 0, uv moves, or the points uv moves from 2 pi 2 pi to 0 0. So we'll have this point will be 2 pi 2 pi. Okay, and so this will be that. So this is 0 0. Okay, so this is the image of this S1. This is the image of S1, right, in UV plane. Now next is S2. On S2 we have S2 is this. From this we know S2 equal to S2 is a line from 0 0 to 0 pi. Here we know that x is a constant, x equals 0, which is constant, and y varies from 0 to pi. Okay, so we have on x2 we have x equals 0 and y varies from 0 to pi. The orientation is like this. Okay, so we have therefore on that line u equal to x is here, so u equal to x plus 2y, therefore x equals 0, therefore u equal to 2y, since u equal to x plus 2y, and v equal to x minus 2y, since x equals 0, we have v equal to 0 minus 2y, that is minus 2y. So eliminating y from these two equations, we get u equal to minus v, or v equal to minus u. So the line will be this is v equal to minus u, this is v equal to u. Okay, so now we need to know what is the from what point to what point we need to move along this line v equal to minus u. Okay, now actually S2 is a line from 0 0 to 0 pi. Okay, 0 0 to 0 pi, so we have 0 0 to 0 pi. So on 0 0 we have y equal to 0, therefore we have u equal to what is this, u equal to y, that is also 0, u equal to 0 and v equal to 0 from this. Therefore the point is uv equal to 0 0. So the image of 0 0 in xy plane, that is xy equals 0 0, the image of xy equals 0 0 is uv equal to 0 0. Okay, and the to find the image of 0 0 0 pi, we have here y equal to pi, so therefore u equal to 2y, that is 2 u equal to 2 pi, and v equal to minus 2 pi, because v equal to minus 2y here. That means therefore the point corresponding point is uv equal to 2 pi minus 2 pi. That means as we move in xy plane from 0 0 to 0 pi, we move in uv plane from 0 0 to 2 pi minus 2 pi. So this is the 0 0, the point 0 0, and 2 pi minus 2 pi will be like this point. This is 2 pi minus 2 pi. Clear? So this line is the image of the line S2. Okay, that is S2 is 0 0 to 0 pi. Now we need to find the image of S3. Okay, to find the image of S3, we have on S3 x plus 2y equal to 2 pi, x plus 2y equal to 2 pi, and from this we can say that x varies from 0 to 2 pi on x plus 2y equal to 2 pi, right? So on S3 we can write like this. On S3 we have x is equal to, sorry, x plus 2y equal to 2 pi. So x plus 2y equal to 2 pi, and x varies from 0 to pi. Yeah, so it's 2 pi. X varies from 0 to 2 pi. So we can write like this. Okay, so x plus 2y equal to 2 pi means we have our the change of variables is x plus 2y equal to u and x minus 2y equal to v. So here we can write x plus 2y equal to 2 pi means u equal to 2 pi. So this is a line, straight line parallel to the v axis. Okay, that means at the point x equal to 2 pi. So this is the line u equal to 2 pi in uv plane is this is the point 2 pi and this is the point 2 pi. So the line will be like this. Okay, so this will be the line u equal to 2 pi. This point is u equal to 2 pi. Okay, so now here this line S3 is passes from 0 pi to 2 pi 0, 0 pi to 2 pi 0. So 0 pi to 2 pi 0. Okay, so we got u equal to 2 pi as the image of S3. That means this line is the image. Okay, now we need to know what is the range of v. Okay, range of v in this line. Okay, that means we have the point 0 pi, we are, as we move from 0 pi to 2 pi 0, actually 0 pi implies we have v equal to x minus 2y, so this is equal to when x equals 0 and y equal to pi, we have this is minus 4 pi, that is minus 2 pi, and u equal to sorry, this is minus 2 pi. That means the point is this is u equal to 2 pi, that is uv is equal to 2 pi comma minus 2 pi, and corresponding point 2 pi 0 implies we have v equal to x minus 2y, which is equal to x equal to 2 pi here, so 2 pi minus 0. Therefore the point is uv is nothing but 2 pi comma 2 pi, because u is 2 pi is a constant here, and v equal to 2 pi corresponding point. Okay, so as we move from 0 pi to 2 pi 0 in xy plane, the corresponding image of that points will move from 2 pi minus 2 pi to 2 pi in uv plane. Okay, so 2 pi minus 2 pi to, so that means this is that point, 2 pi minus 2 pi is this point, and 2 pi is this point. So this line is, this is the line which is uh, which is the image of S3. Okay, so this is the image of S1, let it be S1 dash, this is S2 dash, and this is S3 dash. So image of S1 is this line S1 dash, image of S2 is this line, and image of S3 is this line. So here R is the region bounded by these three lines. Therefore, our the image of this region R is this region. The entire region bounded by these S1 dash, S2 dash, S3 dash in UV plane. This is UV plane. Okay. So here, so we need to integrate. So here we need to integrate this integrand with over this S. Now that means this R is changed to this region S. Let this be, this is S. Clear. So now what about dou xy divided by dou uv? Okay. Now dou xy, we already know that x is equal to sorry, x plus 2y equal to v, and x minus 2y equal to u. So from this, so to find dou xy divided by dou uv, here we know that x plus 2y equal to u, and x minus 2y equal to v. Okay, so from this we have adding this, we get 2x is equal to u plus v, that implies x is equal to u plus v divided by 2. Okay, and subtracting this from this second, subtracting the second one from the first one, we will get this. That means u minus v equal to, this u minus v is equal to 2y minus 2y, that is 4y. That implies y is equal to u minus v divided by 4. That means we expressed x and y in terms of u and v. Okay, so now we can find the Jacobian matrix in dou x dou xy divided by dou uv. We know this is nothing but the determinant dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So from this we have dou x by dou u is nothing but this 1 by 2. Dou x by dou v is also 1 by 2. Dou y by dou u is 1 by 4, and dou y by dou v is minus 1 by 4. So finding the determinant, we will get minus 1 by 8 minus 1 by 8, that is minus 2 by 8, that is minus 1 by 4. So this is the Jacobian determinant. Therefore we can find the integral as, so one implies we have double integral over R, the required integral is equal to double integral over S sine u cos v into modulus of minus 1 by 4. Okay, modulus of minus 1 by 4 into dA dash, right? Because we have replaced the sine u cos v, dou xy divided by dou uv is nothing but minus 1 by 4. So we need to find the we need to replace the modulus of that. Okay, so this is equal to 1 by 4 into integral sine u cos v d v d u. So here we need to write the limits of u and v. Okay, but we have, this is our s, so we have limit of we can take the limits as, from this we have x varies from, or sorry, u varies from 0 to 0 to 2 pi, and v varies from this line to this line. Okay, so we can take this as u varies from 0 to 2 pi, and v varies from this line is minus u to v equal to u. Okay, so v varies from minus v to u to u, and u varies from 0 to 2 pi. So we can write this as u varies from 0 to 2 pi. We are taking the outer integral as constant, and v varies from minus u to u. So first we have to integrate the inner integral with respect to v, which is equal to 1 by 2 into integral u from 0 to 2 pi. We can take sin u as a constant. Now integrating with respect to v, cos v, integrating cos v with respect to v, we have minus, sorry, sin v from v equal to minus u to u into du. Or you can write this, the cos v is an even function, so we can take two, we can write this integral as 2 into integral uh, 0 to v. Okay, you can write like this. So this is 1 by 4 into integral u from 0 to 2 pi sin u into applying this limit, we get sin u minus sin minus u. Okay, du. So this is equal to 1 by 4 into integral 0 to pi sin u minus sin u, sin minus u is minus sin u, that is 2 into sin u du, that is sin square u. So this is equal to 2 by 4, or we can write this as 1 by 4 into integral 0 to 2 pi sin square u. We know sin square u is 1 minus cos 2u divided by 2. Therefore 2 sin square u equal to 1 minus cos 2u into du. Okay, so this is equal to, so integrating this, we get with respect to u, we get u minus integral of cos 2u is sin 2u divided by 2 from u from 0 to 2 pi. So applying this limits, we'll get 1 by 4 into 2 pi minus 0, now minus 1 by 2 into sin 4 pi, sin 4 pi minus sin 0. So we know sin 4 pi is 0 and sin 0 is also 0. So here we have 2 pi by 4 only. Okay, this terms will be 0, and this is 2 pi by 4, that is pi by 2 as the answer. Now we can discuss another example. Evaluate double integral over r xy dA over the region R shown in figure. So here this is the R, region R. So here the integrand is quite simple, but the region R is not at all simple. To integrate this, the integrand over this region R, we need to perform three integrals. That is by splitting this region R into three regions like this. Okay, so we have to split this region like this, and we have to integrate the integrand with respect to over these three regions, and we need to add this the respective integrals. Okay, so but by changing the order of, by changing the variables, here we can do this, or we can find the integral of this, the integral simply. Okay, here here the region R is bounded by these four curves. One curve is xy equal to 1, and second curve is xy equal to 5. Third curve is y equal to x square, and then last one is y equal to 4x square. Okay, so from this, that means this our region is bounded by these two curves, and or this and these two curves, right? Bounded by these two curves and these two curves. So for the intersection will be this point, this region. Okay, so here from this boundary of this region, we know that xy equal to 1 to xy equal to 5, xy equal to 1 to xy equal to 5. So we have from that xy equal to 1 to xy equal to 5. This curve to this curve. Okay. So if we replace also we have this curve to this x y equal to x square to y equal to 4x square, y equal to x square to y equal to 4x square. Okay, so if we replace this from this we can say that y equal to x square to y equal to 4x square means we have y by x square equal to 1 to y by x square equal to 4. Y by x square equal to 1 to y equal to x square y by x square equal to 4. So if we change the order, change the variables like u equal to, if you replace u equal to y by x square as the one of the changes of the variables u equal to y by x square, then we have y by x square is varies from 1 to 4, therefore u varies from 1 to 4, that is 1 less than or equal to u less than or equal to 4. Okay, now the second variable we can take as here xy equal to 1 to xy equal to 5. So if we use v or replace v or xy as v, that is if you put v equal to xy as the new variable, then we have xy varies from 1 to 5, therefore v varies from 1 to 5. Okay, that means if you take this as the changes of the variables, that is if you change the variables as u equal to y by x square and v equal to xy, then we have 1 less than or equal to u less than or equal to 4 and 1 less than or equal to 5 sorry, v less than or equal to 5. That means this region R in xy plane can be converted to the rectangle u varies from 1 to 4 and v varies from 1 to 5. So we'll have like this. If this is u and this is v, then this is v varies from 1 to 5 and u varies from 1 to 4. So we'll have this rectangle. Okay, this is S. U varies from 1 to 4 and V varies from 1 to 5. Right. So this R is the image of R in XY plane is S, this rectangle S in UV plane by using this transformation or by using this change of variable. Okay, so by using this change of variable, our integral becomes in double integral over r xy dA is equal to, we can write like this. Therefore, double integral over r x into y dA can be written as double integral over s in UV plane xy can be replaced by, we have xy is replaced by v, so v into modulus of dou xy divided by dou uv into dA dash, where S is this rectangle, okay, which is the image of R in UV plane. Okay, so here we have we can write this the limits of S are U varies from 1 to 4 and V varies from 1 to 5, and now here we need to find dou xy divided by dou uv. Okay, so for that first we can find dou uv divided by dou xy, and once we find this dou uv divided by dou xy, we will get dou xy divided by dou uv as the reciprocal of this. Okay, so this is equal to, we know dou uv divided by dou xy is nothing but dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, which is equal to dou u by dou x is, we have u equal to y by x square, so dou u by dou x is minus y by x cube. Okay, and u equal to, and dou u by dou y is 1 by x square. Now dou v by dou x is, since v equal to xy, we have dou v by dou x is y and dou v by dou y is x. So this is equal to minus y by x square minus y by x square. This is equal to minus 2 by, yeah, it's a mistake, minus y by yeah, this is minus dou u by dou x is minus 2y by x cube, right? So minus 2 minus 2y by x cube minus y by x cube, that is minus 3, this is this minus 2. So this is equal to minus 3y by x square, right? minus 3y by x square. So we can write this as minus 3 into y by x square can be replaced by u. So minus 3u. Therefore, dou xy divided by dou uv can be written as 1 by minus 3u. That is minus 1 by 3u. Okay. So we have that is we obtain we found dou uv divided by dou xy instead of dou xy divided by dou uv. So we changed the variables y and x here to u and v because dou xy divided by dou uv will be in terms of u and v. So we changed the xy into u and v. Okay. So from this we get our integral is nothing but 1 implies double integral over r xy dA can be written as double integral over s, and the limits of s are v varies from v varies from what 1 to 5 and u varies from 1 to 4. Here is v into modulus of minus 1 by 3u into du dv, right? So this is equal to, so we have modulus of this is nothing but can write this as v from 1 to 5 and we can take minus here is positive 1 by 3, so 1 by 3 or v by 3 into integral u from 1 to 4 1 by u du dv. Okay, so first we need to integrate with respect to u. Thus we have integral v from 1 to 5 v by 3 into integral of 1 by u with respect to u, that is ln of u from u equal to 1 to 4 dv. So this is equal to integral v from 1 to 5 v by 3 into ln of 4 minus ln of 1. We have ln of 1 is 0, so this is equal to integral v from 1 to 5 v by 3 into ln of 4 dv, since ln of 1 is equal to 0. So this is equal to ln of 4 divided by 3 into integral 1 to 5 v dv. So this is equal to ln 4 divided by 3 into v square by 2 from 1 to 5. So this is equal to ln 4 divided by 3 into, or ln 4 divided by 6 into 5 square is 25 minus 1 square is 1. So this is equal to ln 4 into 24 divided by 6 is 4. That is 4 ln 4 will be the required answer. Okay.